chapter, we will learn some basics of probability and statistics that are extremely useful in machine learning. By the way, probability and statistics are very fundamental areas in mathematics which are super important in machine learning. Let me motivate you why probability and statistics are important before we go and understand a few important ideas in probability. So for example, let's take this case that we saw, right? This is one of the pair plots. It's a scatter plot between petal width on the y-axis and petal length on the x-axis. This is from our iris dataset that we saw in exploratory data analysis. Now let's assume that I have a data point. Let's say I have a data point here. Okay, suppose I get a new flower. This thick blue point is a new flower that I got. So I picked up a new flower from the garden, from the iris family, of course, and I found that its petal length is this much. It's about 5, and its petal width is roughly about 1, 2, 3. It's about 3 units, right? Now the question that arises to my mind is this flower versicolor, your orange color, your orange type of flower, which is versicolor here, or is it a green one, which is virginica? Now the question here is, if you notice on your in this scatter plot, your setosas are very well separated from your versicolors and virginicas. This is the region that you have your versicolors, and this is the region where you typically notice your virginicas. Now given a point here which is in the intersection of these two regions, this is your versicolor and this is your virginica, right? Now can you say that your new flower that you picked up, so let's call this new flower that you picked up XQ, where Q, subscript Q, stands for query point, right? This is the query that I'm asking, which is what does this new flower with petal length equals to 5 and petal width equals to 1, 2, 3 equal, is this a verse? I know for sure it's not setosa, but is it versicolor or virginica? To answer that simple question, I cannot exactly say whether it's versicolor or virginica. So instead of saying whether it's Virginia or versicolor, what if I say that I think that this new flower, your query flower XQ, belongs to virginica. Let's say it belongs to it belongs to versicolor with a probability of 0.8, and it belongs to virginica with a probability of 0.2. So what does it mean? So let me put that in simple English terms. I could say that instead of either declaring your XQ as either virginica or versicolor, I could say I think there is an 80% chance. 0.8 basically here implies 80%. 0.2 implies 20%. I could say that there is an 80% chance that it belongs to versicolor, and there is a 20% chance that it belongs to virginica, and there is a 0% chance that it belongs to setosa, right? It's sometimes important to give because a task is classification, but we're not able to exactly classify a data point that lies here into virginica or versicolor. So instead of being very decisive in calling it virginica or versicolor, what if I give a probabilistic score or a chance-based score? I think there is an 80% chance it is versicolor and 20% chance that it's virginica, right? This is where probability seeps in. This is how probability is used in machine learning, to put it very simply. So let's go back to our original example here and to our original topic, which is, so we've just seen how probability or chance plays a very important role in machine learning, especially in the task of classification that we just saw. We also learned a bunch of concepts like histogram. We just saw them, right? When we were plotting for exploratory data analysis, we learned ideas like probability density function, cumulative distribution function, and things like that. We also learned ideas like mean, variance, standard deviation, etc. All these are concepts actually in probability and stats. All these are actually concepts in probability and stats. Even though we learned them in exploratory data analysis, these are all very, very fundamental ideas. We saw how we could use histogram or PDF to understand which feature is important. We just saw that in the previous chapter, right? So all these are very, very interesting and important ideas that we will learn in more detail in this chapter of probability and statistics. Now, having understood why probability and statistics are important areas to study, and since we have motivated ourselves from the simple example of classification of iris flowers that we just saw, let's go and understand some notation, right? So the first important idea is called an idea of a random variable, right? So we know what variables are in programming, right? A variable in a programming is, I could say, x equals to 2. Here x is a variable which could take any integer value, for example. Then I can change it from change x equal to 2 to x equal to 3. It's a similar idea, except that a random variable basically can take one of the can take multiple values. So let me, instead of defining it in a very abstract sense, let me define it with an example. So let's assume I have a dice with me. A dice has 6 sides, right? A dice has 6 sides, 1, 2, 3, 4, 5, 6, right? A dice is something that we all played snakes and ladders as kids. If you're from some parts of Asia, or dice are something that you must have played in a casino, right? So a dice has 6 sides, and if I roll a die, let's assume I roll a die, right? Now, when I roll a dice, I can get any of these outcomes, right? Let's assume it's a fair die. Let's assume it's a fair dice, right? If I roll a fair dice, what is the chance? So let me call, if I roll a fair dice, I can get any of these outcomes, and all of these outcomes are equally likely, to arrive at. So I could define a random variable as x, which is the outcome of an experiment. The experiment here is nothing but rolling a dice. And rolling a dice is an experiment which can have a random outcome. It can have any one of the 6 outcomes here, right? So a random variable basically is a variable which can take outcomes of any outcome of a random experiment, right? Or a random phenomenon. So your x can take a value of 1, can take a value of 2, 3, 4, 5, or 6, right? So here x, typically random variables are represented with a capital X or a capital Y or a capital H, right? So suppose on the other side, you might have already studied probability in your 11th or 12th grade, or even in undergrad first year. Typically, that's what people study in engineering or science or math. So having understood this, let's take another example of tossing a coin. Let's take the tossing of a coin, right? Tossing of a coin is a random experiment. Let's call that random variable as y. What all values can it take? It can take head or tail, right? And both of them are equally likely. So I can call so here y is also a random variable which can take one of the outcomes of this random experiment, which is nothing but tossing a coin. Now, since we have understood what a random variable means, let's also understand some more notation here. So let's stick with a rolling a dice example or experiment, right? So what is the probability? I'll try and read equations in English so that it becomes much easier to understand. I strongly recommend each of you to read your equations in English so as to digest the gist of it, the idea behind it, right? So the probability of, so let's assume x is my random variable, which can take values 1, 2, 3, 4, 5, or 6, right? Here x is a random variable which can take one of the outcomes of my random phenomenon here, which is rolling a dice. So what is the probability that x equal to 1? Since all these events are equally probable, there are 6 events, all of them equally probable. The probability that x equals to 1 is 1 by 6. Right? Similarly, probability of x equals to 2 is also 1 by 6. Right? Now, what is the probability that x is an even number? So how many even numbers are there? There is 2, 4, and 6. So of the 6 outcomes, where each of them are equally likely, 3 outcomes are even, which means the probability that x is even is is actually 1 by 2. Right? You can write it as, since I have 3 events, so you can also write it as probability of x equals to 2 plus probability of x equal to 4 plus probability of x equals to 6. Remember, when I get my random variable having a value of 2, it means it's exactly 2, it's not 4 or something. So which is nothing but 1 by 6 plus 1 by 6 plus 1 by 6, which is nothing but your 1 by 2. And similarly, the probability that x is odd is also 1 by 2, right? So this is a simple notation. So whenever you see something like this, you should read it as probability of a random variable x taking a value of 1, right? And this notation can sometimes get very, very hard. So for example, I could write probability of x equals to x1. So what is this? Let's learn how to read this. It means the probability that a random variable takes a value of x1. Sometimes this is written in shorthand as just as a notation. We're just learning notation here. No major leaps of understanding, no major grand concepts yet. Right? This is simple notation. Instead of writing this whole term here, if I know that the random variable is x, sometimes people write it as probability of x1. Right? This is a much more concise and more compact way of writing the same thing. Of course, here I should understand that it is a random variable x here implicitly, right? So this is a simple notation of writing probability of a random variable taking a value. Very, very simple notation. This is just notation till now, right? So now let's understand two types of random variables. Your dice rolling. So let's assume x is your dice rolling. X is the outcome of rolling a dice. It can take one of the 6 values, 1, 2, 3, 4, 5, 6. Now let's take another random experiment, which is I pick a student in a class and I measure the height of a student. Height of a randomly picked student in a class, right? Let me call that random variable y. Now this y, let's assume that most students, most human beings, let's assume, just for simplicity, lie between 120 centimeters and let's say 190 centimeters, right? So your y can take any value between 120 and 190. Of course, there might be some people who are shorter than 120 or who are taller than 190, but mostly people lie in this region. So your y, which is nothing but height of a randomly picked student in a class, could be something like 162.45 centimeters. Or your y could be your 132.62 centimeters. It could be any real number here, right? Now, a random variable which has a set of outcomes. So here my outcome, so my x can take one of the 6 values. It can't take 7 or it can't take 4.5. So if a random variable can take one value in a set of values, in a finite set of values, it's called a discrete random variable. Because it can only take one of the values from a discrete set. While a random variable like y, which can take any real value here, is called a continuous random variable. Again, I'm just defining terms here. I'm not explaining some grand concepts as I just told you a while ago. We're just learning what a bunch of terms mean. So a discrete random variable is a random variable which can take values from a set of values, while a continuous random variable is basically a random variable which can take any real value in this case, right? So this is also a very simple idea of what a continuous and a discrete random variable is. We'll understand a related concept that we encountered a while ago when we were learning about mean and medians of an idea called an outlier. I just wanted to quickly go over this idea because we'll keep revisiting this idea. Suppose let's assume I have y, which is height of a student in a class randomly chosen, right? Now let's assume I collect lot of observations for my random variable y. Let's assume I picked one student and the student height is 122.2 centimeters. I picked one more student whose height is, let's say, 146.4 centimeters. Let's assume I picked one more student who is 132.5 centimeters, so on and so forth. So when I picked a lot of observations like this, let's assume I got an observation which is 112.26. Let's just assume, and then I got again 156.23, etc., etc. Now you'll notice that all of my numbers here, right, are within a sensible range of what a height of a student here, except this number, right? Such a number, such an observation is called an outlier observation. And outliers can happen because of multiple reasons. So in this case, the outlier could have happened because somebody, instead of saying 122.6, mistakenly entered the value as 12.26, right? So it could be human errors. It could be observational errors. It could be that there is actually one person. So for example, we have one more value here, which is, let's say, 92.6, right? You could call that also as an outlier, but it could just be a person who is very short, who has some genetic abnormality, and hence that person is very short, and he or she happens to be in our class, right? This is also an outlier. So outliers could happen, could be present in your observations because of various reasons. It could be human errors, it could be genuine outlier, right? But outliers can corrupt your signal. For example, we saw while earlier when we were learning about mean and median that mean can easily be corrupted because of a single or a small set of outliers, right? So mean can be corrupted by outliers. Means get impacted by outliers. Similarly, your variance also can get impacted by outliers. And hence, we learned a concept called a median. Similarly, we learned concepts like median absolute deviation to avoid the problems of outliers.